everyone, we have made a project repository portal using MySQL and Java. In colleges, when we look for problem statement or want to start a new project, initially we need some guidelines. These guidelines can be given by any student or mentor who had already worked on similar problem statement. But at least in our college, currently we don't have any database that has details of the project done by our college student and also the contact details of the respective students and mentor. So we decided to alleviate this issue, and hence we created a project which will let the user sign in into our portal and search the database using keywords from which the user will get the information about similar project and also the contact details of the students and the mentor who had worked on the respective project. We used MySQL and Java database connectivity to tackle this issue.
So I'll now take you through the database. The project repository database is a MySQL database which is designed to store information related to the research projects and their associated mentors and authors. This database provides a structured and an organized approach for managing project information, allowing users to easily add, edit, and view the project details through a front-end Java GUI application. By using this database, researchers can easily track project progress, monitor the team members, and maintain records of the research activities. I'll now guide you through the details of each and every table which is included in this database. This database has three main tables. The first one is authors. So the first one is mentors. The second one is authors. And the third one is projects. The mentor table contains the information about the mentors who supervise the research projects. Each mentor over here is identified by a unique mentor ID, which is automatically generated by the database. The mentor name and the mentor email, the mentor name as highlighted here, and the mentor email are the fields which contain the name and email address of each and every mentor respectively. The mentor email field has a unique constraint applied to it to ensure that each mentor has a unique email address. So this is the query wherein we are entering the data into the mentors table, and this is the corresponding output that we get over here after executing the query. So after the execution of this query, each mentor will get a unique mentor ID which will get associated to the respective mentors. Now let's look at the authors table. The authors table contains the information about the authors who work on the research projects. Each author is identified by a unique author ID, which is again automatically generated by the database. We also have the author name and the author email as uniquely identified attributes in this table. So again, this is some of the data entry that we have done for the project demo, and here we have the output for this. Once the authors table is generated, again the author IDs would be associated to the respective authors automatically through the database. And lastly, we have the projects table. The projects table contains the information about the research projects. Each project is identified by a unique project ID, which is automatically generated by the database. The project title, as highlighted, the project abstract, which contains the brief summary of the project, then the author ID, which is associated with the project, and the mentor ID, again, which is associated with the project. So these fields, like the fields author ID and mentor ID, are the foreign keys that reference the authors and mentors table respectively. We choose to put the author ID and mentor ID as foreign keys in this table since an author or a mentor can have multiple projects. So a key example for that is this project has a mentor ID of 1, and again the project which is listed next to the first one also has the mentor ID 1. Hence as we discussed, one mentor can have more than one mentor or an author can have more than one projects under them. So yeah, by using this database, the front-end Java GUI application can access and manipulate the data stored in this database, therefore allowing users to view, add, edit, and delete information about the research projects, authors, and mentors accordingly.
So we have now seen the structure of the MySQL database of our project. Now I will walk you through the 1000 plus line source code that utilizes Java database connectivity to connect our Java program to the MySQL database.
So here we have the source code of our project. Before we dive into the source code, I'd like to show you a quick demo. So we run the driver code. A menu pops up. So we can sign up first. We need to enter our name, our email, let's say dev@gmail.com, and a password. The sign up was successful. Now we move on to the login page. So we log in with the same credentials as we signed up with. We enter our password and we are in. So now we can add a new project, view our own projects, and do other things. But first we need to add a project for our own updation, deletion, and insertion operations. So we add a new project. The project title, let's say, is sample project. The abstract is this is a sample project. The mentor ID, let's assign a random mentor ID, and the project was saved. So now we can tap 4 to view our own projects. So we can see this output, all the projects that we had created with our own author ID. 6 was our author ID. And now we can search projects by keyword. So in the repository, we can, let's say we go for satellite. This searches the whole repository for satellite wherever in the title or the abstract. If satellite is present, it will output that project. Let's say we again search for 5. We again search for a keyword, let's say infrastructure. So we've got, this must be in our repository. That is why we've got it as an output. Now we can update the project title, update the project abstract, add a new mentor, change project mentors, or even delete a project. Let's say we choose to delete a project. So if we had the project ID for our project, sample project, the project ID was 6, and we choose to delete the project, and it asks us to confirm, and we say yes. So the project was deleted. Now we can view our projects, and it will not show any output because we don't have any projects. We can enter 0 to end the program. This was a quick demo. Now let's have a look at the models. The models are each of the models represent a table of our SQL database. So for example, the author model has an author ID, author name, and email. All these are instance variables, private instance variables, which are implemented in this program. And now we have a parameterized constructor and an unparameterized constructor. We also have getters and setters for all these instance variables. We have overridden the toString method so that whenever we output our object, we have it in a structured format. Similarly for mentor and for project. Okay, so once we have the models ready, we can move on to the project repo. So the repos are our connection between the Java project and the SQL database. So first of all, I'll show you the dbutil class. What this class does is it creates a connection object and connects our Java program to the SQL database using this URL of the local server, and the username and password are also included. Now, once we have a connection, we need to define the queries. These are the queries for the author table, which will be used as functions in a Java program. So for example, let's say we look at the insert author query. It will say insert into authors, the author name, author email, the values that are marked as question marks as placeholders. So we'll convert all these queries into functions of a Java program. So let's see a function in action. So Here we have the insert author function. It takes two parameters as input, one of them being author name, the other one being the email. Now it fills in that insert author query. So you can see the author queries dot insert author query. This was the same one what we saw here. It will fill these both those question marks with the author name and the author email over here, and then it will execute the query. Similarly, we have defined functions for all the other queries that we have for author, and then we've done the same for the mentor and the project. Now we move on to the final bit of our project. When we define project queries, we saw that we have update title, update mentor ID, and also delete project as a query. And we have corresponding functions to execute those queries. But we cannot have anyone deleting someone else's project. That is why we need a login and sign up layer in our project. So here we have the login function, the login class. It helps a person log in using their email and password, and checking that email and password with the CSV file that is stored in our database. The sign up function will similarly let users sign up and store their new information and the credentials into the CSV file. All the project repos, the models, and the services that we created were compiled in this menu-driven driver class. We use system.out.println to create a menu and a switch case to call all the relevant functions. That is the end of our project. Thank you for watching.